Welcome you all for the complex variable lecture series. In this lecture, we want to discuss in a complex variable one of the important function, that is transformations related to complex variable. That is, first we will start with a transformation. That is, if we can trace a curve in one plane with respect to some points on the other plane, then we call the curve is transformed. Means any function here, one of the function is in the, here there are two planes will be there. If it is in the z plane, after the transformation, what happens in the w plane? That is the first fundamental thing we will discuss in this transformation. We will discuss some illustrative examples also. First, we will start with a conformal transformation. What is conformal transformation? If any transformation, the magnitude and direction between any two curves, then it is called a conformal transformation. The condition for the transformation W is equal to f of z is said to be conformal if that f of z must be analytic and also the first order derivative with respect to z is non-zero at all the points in that region, then we say that the given transformation is conformal. First, we will discuss some problems related to W is equal to e power z. This is one of the transformation is given. W is equal to e power z. First, we will check that is it conformal or not. Means first you can differentiate with respect to z. E power z is non-zero at, because e power 0 is non-zero, it is not equal to 0 for general points. Then we say that the transformation is conformal. Now we will substitute here the given function w is equal to u plus iv. W is a function of u and v and z is a function of x plus y, means it is a mapping from z plane to w plane. That's why we are making here, that is e power x plus iy is can be written as e power x into e power iy by Euler's formula e cos y plus I sin y. Then this become e power x into cos y plus I sin y. Now we can separate real and imaginary parts here. Here u is equal to e power x cos y and v is equal to e power x sin y. After that, if you are observing, it is in u is in terms of x and y, v is also in terms of x and y is there. First, we can make, if possible, x and y in terms of u and v. That is a transform. Means if you observe here, if you are dividing these two, v by u, then this become e power x become cancel, then you get tan y. Then y is equal to tan inverse of v by u. And similar way, if you squaring on both sides and if you adding this, then this become u square plus v square in the one side, another side e power 2x into cos square y plus sin square y. If you take e power 2x as a common, then you get cos square y plus sin square y. You get a, in terms of e power x, e power 2x is equal to u square plus v square form. Now we will discuss what about the transformation here. If it let it x is equal to c1, x is a constant, means it is a line. This is a straight line family parallel to y-axis passing through the point c1, 0 in z plane. That is the general string we have taken. On squaring and adding, and we already discussed, you get, we have expressed x in terms of u and v. Then that is u square plus v square is equal to e power 2c1. Then you can observe here it is in the form of x square plus y square is equal to constant term, that is a square, means it is a circle equation centered at the origin and radius is equal to e power c1. This is a circle centered at the origin with radius is equal to e power c1. You can see the pictorial representation of that. Here in the z plane we are taken, it is a line in the z plane. After the mapping, it is a circle in the w plane with e power c1 is a center. In same way, if you take y is equal to c2, it is also a line parallel to the, it is a family to x-axis passing through the point 0 comma c2 in z plane. Now, after simplification, I told rearrangement v is equal to u into tan of is equal to u into tan y. That is y is equal to c2. You substitute. This is a straight line passing through the origin in w plane. You see that in generally we can make it as y is equal to mx, or m is a slope. M is a slope means here tan c2 mx form means, but here in place of x and y, here we are using the u and v are the quadrants. That's why you can observe here it is passing through the points. This is a straight line passing through the origin depending on the lines. Here 0 comma c2, if you fix one of them, if you put points for c2, you get lines. Similarly, here in the w plane, depending on the slope, many straight lines will appear. These are the transformation from z plane to w plane. This is one example. Now we will discuss the another example. W is equal to z square. First we can start where it is analytic or not. You can see dw by dz is equal to 2z. It is not equal to 0, then only it is conformal. In this function is not conformal at z is equal to 0. All other point it is conformal. The transformation in w is equal to z square is conformal except at z is equal to 0. Then you can take the transformation, put w is equal to u plus iv and z is equal to x plus iy the whole square, a plus ib form a plus b whole square, that is a square plus b square plus 2ab formula. Applying here, this become x square minus, because I squared is minus 1, then you get minus y square plus 2i into xy. Here, after separating real and imaginary part, you get u is equal to x square minus y square and v is equal to 2xy. Now, in the previous example, I explained u and v in terms of x and y in terms of u and v. Here u and v are in terms of x and y is there. You can transform x and y in terms of u and v. First, let it the standard one. Put let x is equal to c1 is a constant. It is a line, straight line family parallel to y-axis passing through the point c1 comma 0 in z plane. Then that become v square is equal to minus 4 c1 square minus u minus c1 square. If you observe this, it is in the form of y square is equal to 4a into x, means it is y minus y1 the whole square, that is a parabola, that is y minus y1 y square is equal to 4ax, that is the form. Here shifting to the origin, here x minus x naught, that is the formula. Here we can make this is a parabola symmetric to the real axis with the vertex at c1 square comma 0 and focus at the origin. You can see the diametrical representation of the above case, that is c1 comma 0, then it is mapped onto c1 square comma 0 in the w plane. It is a parabola. Similarly, if you case 2, y is equal to c2, a constant, this is a line, straight line parallel to the x-axis passing through 0 comma c2 in the z plane. Then that is also, if you simplify, v square is equal to 4c2 square plus u plus c2 square. Means again it is also a parabola, but it is symmetric to the real axis with the vertex set at minus c2 square comma 0. Here plus is there, that's minus, and focus is at the origin. You can see here. This is the z plane. After the mapping, it is a parabola. Here you can see in the w plane. Let's consider one more case. Let us consider a circle of radius r at the origin in the z plane. Means mod z is equal to r means centered at the origin and radius is equal to r. Means w is equal to z square r square e power 2 theta. Then comparing this is a circle of radius r square and subtended to an angle 2 theta. Means radius is r square and subtended to 2 theta. Means here this is a theta become 2 theta and r is the radius, that become r square is the radius in the w plane. Circle of in the transformation become circle become bigger circle. Now we will discuss one more transformation, bilinear transformation. Any transformation is in the form of W is equal to AZ plus B divided by CZ plus D, where A, B, C, D are complex constants and AD minus BC is non-zero. Then we call that as bilinear transformation. Means it is a linear in Z as well as linear in W. That's why we say that it is a bilinear transformation. We will note that some of the every bilinear transformation maps circles or straight lines in a z plane to a circle to circle, as well as straight lines to straight lines in a w plane. And also the cross ratio of w minus w1, w2 minus w3, w1 minus w2 and w3 minus w1. It is a cyclic, that is a cross ratio, also satisfies the bilinear transformation. Means here w minus w1, w2 minus w3, w1 minus w2 into w3 minus w is equal to the z minus z1, z2 minus z3, z1 minus z2 into z3 minus z. Means in the bilinear expression we can use this cross ratio formula also. Now we will give some examples related to bilinear transformation. Find the bilinear transformation which maps the points z is equal to 1, I and minus 1 is given. On to the points w is equal to corresponding to z is given I 0 minus I, means 1 to I to 0, minus 1 to minus I. Start with given, we can write w1 is equal to I, w2 is equal to 0 and w3 is equal to minus I. Similarly, z can be, first one is z1 is 1, z2 is equal to I and z3 is equal to minus 1. Then apply cross ratio. We can recall the cross ratio formula, and corresponding to this we can substitute w1, w2, w3, z1, z2 and z3. Then we get, after substitution we get this one, w minus I, 0 minus of minus I divided by I minus w, etc. Then here we can make some simplification, that is w minus I divided by w plus I, because here I become cancel and simplification version is this one. Then conjugate of this can be done here, or comparendo dividendo rule also you can apply, that is w minus I plus w plus I, that is 2w, and minus w 2I. Then this become, after simplification, that dividendo formula if you apply, then that become minus 2w divided by minus 2I. After simplification is this 2 times z minus I. All other terms become simplified. And similarly here minus 2 minus 1 and minus 1 is there, that is minus 2, and here iz that is 2I z will be there. If you take minus sign common, you get minus 2 times 1 minus iz. 2 all will be cancelled to each other. Minus sign is also w by I is equal to z minus I. You can transform in the numerator, then that becomes iz into I is minus 1, that is plus 1 minus iz. That is 1 plus iz divided by 1 minus iz is the function. One more example related to bilinear transformation. Find the bilinear transformation which maps the point z is equal to 1, I and minus 1 onto the points w is equal to 2, I and minus 2. First, let it that given function can be represented w1 is equal to 2, w2 is equal to I and w3 is equal to minus 2. And z1 is equal to 1, I and minus z1 is equal to 1, z2 is equal to I and z3 is equal to minus 1. Then we can recall the cross ratio formula for a bilinear transformation. Then corresponding of w1, w2 and w3 substitute the values. Similar way z1, z2 and z3 substitute here, then you get this one. After substitution, rearrange the things. Whichever is simplified, you can make a simplification. After that, you can use by compendo dividend rule. That is, you know that the cross multiply w minus 1 I plus 2, that is w minus I plus w plus I, w minus I minus wi minus y, then this becomes z minus 1 into I plus 1 plus 1 minus I into z plus 1 into the simplification terms you are getting here, that is w by I is equal to z minus I divided by 1 minus iz. Simplified, you get 1 plus iz divided by 1 minus iz. One more examples related to bilinear transformation. First, which maps 1, I and minus 1 onto the points 2, I and minus 2. You can take as it is, substitute in the cross ratio formula. Cross ratio is w minus w1, w2 minus w3 divided by w1 minus w2, w3 minus w1. Similar way here also, substitute and rearrange this and use compendo dividend rule here. Then for this function compendo dividend rule, then that become, you get this, after simplification you get w is equal to 2I minus 6z divided by iz minus 3. One more example, find the bilinear transformation, maps the point z is equal to minus 1, I and 1 onto the point w is equal to 1, I and minus 1. And some more examples related to this. Suppose anywhere the infinite term is given, you can write it as 1 by 0 and rearrange. Here one of the examples, find the bilinear transformation which maps the z is equal to 1, I and minus 1. Here you can treat that as 1 by z. You can write, first you can make it in z as a common factor. Wherever the term infinity will be there, you can rearrange, you get the simplification pattern. Don't write infinity. It is, you can take 1 by z, then that become 0. Thank you.